Okay, this video is all about the extreme value theorem. So let's first of all talk about what an extreme value is. So our two are minimums and maximums. Okay, so the minimum is the y value, right, on this interval for some given x value where it's the largest, right? The y value is the largest of all the values on this interval, and the minimum is the smallest of all the y values on this interval. Okay, so the answer is not really necessarily what your y value is, but what is the x value where that maximum or that minimum occurs. Okay, so we're going to have a maximum at x equals some number, or we're going to have a minimum at x equals some number. Okay, and we can have many of them. That could be a couple of maximums, like a mountain range has different heights of mountains in that range. There is one tallest mountain in the range, but there is one tallest mountain in the world, right? That would be the absolute versus the relative or the locals. So here we have a nice closed interval from -2 to +4. And we want to figure out where is our absolute maximum on this. So what are these 4 points? What is the highest y value? 21 is the highest value. And where does that y value occur? At x equals 4. Okay, so the answer to this, f has an absolute maximum at x equals 4. Right? It's not asking for what is the y value. It's asking for where is it occurring. Okay, f has an absolute minimum at -2. So -15 is the smallest value, and that occurs at -2. Okay, it has a relative maximum at x equals 0, right? Our relative maximum is 5, the top of that little hump there. And the relative minimum is going to be at x equals 2, which has a relative minimum of 1. Okay, so that's what we're going to be doing, is we're going to be figuring out where are these points. Okay, and these are called critical points. As you see here, critical points. So a critical point is where your derivative is either 0 or not defined. Okay, so we're looking for where is our derivative 0. That would be your horizontal tangent lines. Right, so here at our relative maximum 0, 5, our local maximum, this would have a horizontal tangent line, right? A first derivative of 0. And here at your local minimum, we would have another horizontal tangent line. Okay, so we want to figure out what are the zeros of your derivatives, or where is your function not differentiable. Okay, so that would happen at a cusp. Right, if we had a cusp in our graph, which is like this is a cusp, that point right there. A function is not differentiable at a cusp. Or if it potentially had a vertical tangent line. So if our derivative graph looked like this or something, and we had a vertical tangent line, the derivative would also be undefined at those places. Okay, so that's what it would look like at a graph for our function to not be differentiable. So let's look at these little pictures here and see if we can come up with some thoughts, what conditions we need to have. Okay, so where are we going to have a minimum on our interval here from -1 to 2? What's our x value? 0. So we have a minimum at x equals 0, and we have a maximum at x equals 2. Okay, a maximum at x equals 2. Very good. Okay, looking at B, where do we have a minimum on this graph? X equals 0 again. And what about our maximum? Well, is this y value bigger than that one? Yes. What about this y value? And this y value? That y value? That one? That one? So what is our largest x value where we're going to have the largest y value? Well, it's not defined at 2, right? Because an open circle means not defined, so we don't actually have a x value at 2. So is it 1.9? Or is it 1.99? Or is it 1.999? Or 1.9, where is it? Where is it going to be? Right, so if we have to do one of these businesses where we keep adding 9s, because we can add 9s forever, that means we don't have a maximum value. Maybe not undefined, but how about none? Or does not exist. Remember that from our limits. Okay, if we have an open circle there, you can always add another 9 to that x value to get a closer, right, a more accurate. So if we have to do that, that means that the maximum does not exist. Right, the limit exists from our limit stuff, but the maximum value does not exist. And what about C? Do we have a minimum value here? No, right? Because there's a hole there at the bottom of our graph where we used to have a minimum, but is it 0.01 or 0.001 or 0.000? Right? If we can add another decimal point somewhere, that means we don't have an absolute minimum. But we have a maximum at x equals 2. Okay, so what needs to happen in order for us to have a maximum or a minimum value? We have to have a closed interval where our graph is continuous. Okay, so on B, we don't have a closed interval. Right, this one goes from -1 to 2 with a parenthesis, right? So we don't have a closed interval for number 2. But for C, we have from -1 to 0 and from 0 to 2, right? So this one is not continuous because we have to make a jump at 0. Okay, so our function has to be continuous on a closed interval in order for us to have a maximum or minimum value. Okay, and that's what we start off with our theorem by saying. So the theorem starts off by stating that our function has to be continuous on the closed interval. Okay, just has to be continuous. There are no gaps, there are no holes, there are no discontinuities, there's no asymptotes, right? All of that stuff. It has to be continuous on your closed interval. And then there's going to be a maximum and a minimum. Okay, is what the rest of it says. So how do we go about figuring out what those values are? Well, that's what we call the candidates test. Okay, so we're going to pick some values to try. And not just any values. We're going to pick some specific ones. Number 1, we're going to find the places where our derivative is 0 or undefined. Once we have those critical values, we're going to evaluate them in the f function. So we're going to plug them back into the given equation at the beginning, your function, and see what those y values are for each of your critical values. Okay, and in addition, you're going to evaluate each endpoint. So our critical values are the zeros of your derivative and the endpoints. Okay, and then you're just comparing those y values. And whichever one has the largest y value, that's where your max is. And whichever one has the smallest y value, that's where your minimum is. Okay, so let's see if we can do the math for a couple of problems here. Find the absolute maxes and mins on the closed interval from -1 to 5. Okay. So our first step is to take the derivative. So this is a polynomial, right? All polynomials are continuous functions. So you want to check the interval if it's a rational function or if it's a square root function, right? Those ones do not have all real domains, but a polynomial does. So our derivative is going to be, so we take that derivative and we set it equal to 0. So 6x minus 24 equals 0. That means my critical value is going to be 4. Okay, so that's one of your critical values. So we have to check what is f at 4. Okay, so we're plugging 4 into our f equation. We're plugging it in up here, right, into our f equation to figure out what is our y value when x is 4. Okay, so that's 3 times 4 squared minus 24 times 4 minus 1. So f at 4 is negative 49. Okay, now we need to check our two endpoints. So what is f at negative 1? And what is f at 5? Okay, so you check your critical value where your derivative is 0. Right, this is your critical value. And then these other two are your endpoints. You plug it into the f equation. Yes, you're always plugging your x values into your f equation. So here are all of your y values. So which one is the smallest? Negative 49 is the smallest. So this is your absolute minimum. And 26 is your largest. So this is your absolute maximum. Okay, so let's talk about how we write this in AP Calculus. Right, so we say f. F is what we're talking about. F of x has an absolute max at where? What is our x value where we have an absolute max? At x equals negative 1. And an absolute min at what x value? At x equals 4. Okay? And what is our interval? Because it might not be true for the entire function, but on our interval, these are your answers. Okay? So we put in, what are we talking about, right? F is who. The what is your absolute max and your absolute mins. And then our x values answer the question, where does that occur? Right, at x equals negative 1 is where we have our absolute max. And at x equals 4 is where we have an absolute min. And then these are your constraints on this interval. Right, because if we change the interval, then we might change our absolute maxes and absolute mins. So make sure you are including the interval that they included in the problem, because that's where you're finding your maxes and mins on that interval. Excellently well done. So when we're finding an extrema, maxes and mins, then we're taking the critical values and we are evaluating them. Okay, here, number B, letter B. Number B, we start with the derivative, which is 18x squared minus 24x cubed. And we set this equal to 0. Okay, so this is a polynomial. We're going to solve it by factoring, but we're not going to do a quadratic. We're going to do a common. What do 18x squared and 24x cubed have as common multipliers? And that's 6x squared, right? They both have a 6 multiplier and they both have an x squared. So 18 divided by 6 is 3. 24 divided by 6 is x. And we still have a x on that term. So here are your factors of 18x squared minus 24x cubed. So now to solve, we set both of our factors equal to 0. Right? If I have two things multiplied together to give me 0, then one of those two numbers has to be 0. So from here, x equals 0. That's the only thing I can multiply 6 by and still get a 0. And on this side, I can move my 4x over here and then divide by 4. So x equals 3/4. So these are my two critical points. This is where I'm going to find a local max and a local min, and maybe the absolutes also. Okay? So now that I have my two critical points, right? These are my critical values. I'm going to plug them into f. So f of 0, right, into my f function to figure out what the y is. F of 0 and f of 3/4. Okay, now I'm going to do this in my calculator. I can do this. 0 plus 0 plus 5. F of 0 is 5. It's really easy to do math with 0 because 0 squared is 0, so I don't have to really worry. But 3/4, I'm going to put this into my calculator to help me out. So these are my two critical y values, and now I have to do the same thing for my endpoints. So I'm going to figure out what f of -1 is and also f of 2. Okay, so these are my critical values. I have their y's, and then I do the same thing for my endpoints because those are all of my candidates. All of my candidates. So there are my endpoints. So looking at my values, here is my maximum, 5.633. And here is my absolute minimum at x equals 2. Okay, so then let's write down the calculus. Right, let's do our final evaluation for our problem. So that's what we're asked to do. Whenever we want to find an absolute maximum, we are using the extreme value theorem. Okay, extreme value theorem. And we're performing the candidates test to decide which of our x values gives you that absolute maximum and that absolute minimum. All right, have a swell day. Goodbye.